Okay, so we're going to sketch this function, y equals 2 times the quantity x squared minus 9 over x squared minus 4. So here on the homework, we're going to just write these. You could write A, capital A, and write in domain or not, but just kind of label this as kind of like part A, part B, part C, and then just write everything down. So domain. A lot of times we have domain involve real numbers, but for this one, it's a fraction, and so we always have to check the numerator or the denominator. Denominator. So the top isn't going to have problems, but the denominator, we could have a problem with division by what? Good. Now it's not guaranteed, but we need to explore that. So if you want, you can just write the equation. Does x squared minus 4 equal 0 anywhere? And if so, where? We'd need to exclude that from our domain. So solve that little equation, and what you should get is, yeah, there are some places where we have some issues. Where is it? 2 and negative 2. Good. So these are excluded from the domain. So here we go. I'm going to write this out in interval notation. Negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Okay, questions on domain? Okay, let's move on to intercepts. Let's do the easy one first, the y-intercepts. That's when x equals 0. So plugging in 0 is pretty easy. When I plug 0 in, on the top I get 2 times negative 9. And then on the bottom, let's see here, I'm going to get negative 4. So reduced, I have 9 halves. To list the y-intercept, you could say the y-intercept equals 9 halves, or what's common is to just write it as a point. And that's kind of handy because actually that's why we want to find the intercepts, is it anchors the points that we're going to need on our graph. And so might as well just write it as a point. So when do we have x-intercepts? When what equals 0? Y. So just set the function equal to 0, and sometimes this can be a little bit more work because we have to do a bit of algebra. Now because our goal is to find the x for which y equals 0, we can just multiply both sides by x squared minus 4 to get rid of it, because that's not going to contribute any solutions. Our problem reduces to 0 equals 2 times the quantity x squared minus 9, which I can go ahead and divide by 9 as well, or by 2, excuse me, and then get 0 is equal to x squared minus 9. So keep solving, and we're going to get what for x? Positive and negative 3. Good. And so this yields the points negative 3, 0, and what? 3, 0. So again, writing it as points is handy because that's actually why we're trying to find these things, is we want to plot those points. Questions? Symmetry. I'm going to write down the function again because it's off the page. If you had to take any guess at symmetry, would you think that it has even, odd, periodic, or no symmetry? What would you guess? There's some even powers in there, right? Okay, so if you're good at detecting this right away, that's great. Otherwise, use the definition to make sure. It is even, but if you're not sure, do the test. So I'll put even question mark. Well, the test is to plug in negative x for x. See if you can do some algebra to get back to f of x. So I'm doing that right now. And notice that negative x squared is x squared. So on the top I get f of x, or the top of f of x, and then the bottom, the same thing happens, and I do get f of x. So I can conclude that it is even. Now here's the deal, you have a choice here with symmetry. If you have even odd symmetry or periodic, then you could just do the part of the graph that is necessary and then use the symmetry to make the rest. Or you can use it as a check at the end of like that your graph makes sense. And so what I'm going to do is I'm going to do everything from scratch, and then I'm going to use the even as a check. Another thing to keep in mind is you will have some problems that have kind of all the summary stuff done for you and you're not given f of x equals whatever and given the function, and maybe you're just told it has a certain kind of symmetry. So you do need a graph with the symmetry that's indicated or know how to do that, but when you have the function, then you have a choice. Does that make sense? Because you have the original function, so you have a lot of flexibility in what you do, and these are guidelines to graphing. So what I'll do for the rest of the problem, I'll use the even symmetry as a check. Could use to only graph half of it in this case, and fill in with symmetry for other half. Okay, next one is the asymptotes. And I think I'm going to stop the recording because this is going to take forever.